Hey guys, today we're going to talk about fossils, and the goal behind today's lesson is to make sure that you can describe how fossils show evidence of not only the changing surface, but the climate of the Earth. So before we get started, let's go ahead and discuss what is a fossil, and after that, let's talk about what fossils actually tell us. Now, a fossil is described as the remains or evidence of a once living thing. Fossils give us clues about organisms that lived long ago. They help to show that evolution has occurred. They also provide evidence about how Earth's surface and climate have changed over time. Now, some information about fossils. First of all, a paleontologist is a scientist who studies fossils. Most fossils are found in sedimentary rocks. The upper layers of rock are much younger than the lower layers of rock. This is also known as the principle of superposition. Fossils are generally most abundant in marine sedimentary rocks and generally are not found in igneous or metamorphic rocks. Now, how is a fossil formed? It begins with sediment. An animal is buried by sediment, such as volcanic ash or silt. Shortly after it dies, its bones are protected from rotting by the layer of sediment. Layers or sediment layers accumulate above the animal remains, and minerals such as silica, a compound of silicon and oxygen, slowly replace the calcium phosphate that is found in bones. Movement. Movement of tectonic plates, or giant rock slabs that make up Earth's surface, lifts up the sediments and pushes the fossil closer to the Earth's surface. Erosion. Erosion from rain, rivers, and wind wears away the remaining rock layers. Eventually, erosion or even people digging for fossils will expose the preserved remains. Now, as I mentioned, fossils show the changing surfaces. They provide clues to how Earth's surface may have changed over time. Scientists have found seashells high in the foothills of the Andes Mountains. This presents a conundrum, which makes us wonder, how did this happen? Well, there are two hypotheses. Either the sea once rose to cover the hills, or perhaps the hills rose from under the sea. Regardless of which hypothesis is correct, we know that the surface of this part of the world has indeed changed over time. Now, it also can be seen in fossils how they affect the changing climates, or how fossils indicate that there is a change in climates. Scientists have found evidence of fossils of corals in Arctic waters. Corals can live only in warm water. The fossils indicate that a long time ago, the Arctic was a warm place. Scientists found fossils of alligators in Canada. Alligators live in warm, swampy areas. The conclusion, therefore, is that Canada was once warm and swampy. Now, there are 5 main types of fossils. There are petrified fossils, molds and casts, carbon films, trace fossils, and preserved remains. Let's talk first about petrified fossils. Here you have an example of a petrified fossil, which is a Tyrannosaurus rex fossil displayed in the Field Museum in Chicago. The word petrified literally means turning into stone. Petrified fossils form when minerals replace all or part of an organism. Water is full of dissolved minerals. It seeps through the layers of sediment to reach the dead organism. When the water evaporates, only the hard materials or minerals rather, are left behind. Molds and casts. This mold or imprint is of an extinct mollusk called an ammonite. A mold forms when hard parts of an organism are buried in sediment such as sand, silt, or clay. The hard parts completely dissolve over time, leaving behind a hollow area with the organism's shape. Cast fossil. This ammonite cast was discovered in the United Kingdom. A cast forms as a result of a mold. Water with dissolved minerals and sediments fill the mold's empty spaces. Minerals and sediment that are left in the mold make a cast. A cast is the opposite of its mold. Carbon films. This is a fern fossil. This carbon film fossil of a fern is more than 300 million years old. All living things contain an element called carbon. When an organism dies and is buried in sediment, the materials that make up the organism are broken down. Eventually, only the carbon remains, and the thin layer of carbon that's left behind can show an organism's delicate parts, like leaves on a plant. Trace fossils. Fancy footwork. This dinosaur footprint was found in Namibia, Africa. Trace fossils show the activities of organisms. An animal makes a footprint when it steps in sand or mud. Over time, the footprint is buried in layers of sediment. Then the sediment becomes solid rock. Preserved remains. Amber. An organism such as an insect is trapped in a tree's sticky resin and dies. More resin covers it, sealing the insect inside. It hardens into amber. Tar. An organism such as a mammoth is trapped in a tar pit and dies. The tar soaks into its bones and stops the bones from decaying. Ice. An organism such as a woolly mammoth dies in a very cold region. Its body is frozen in ice, which preserves the organism, even its hair. So these represent some of how organisms get preserved and are close to their original states. Now, let's look at how trace remains may impact observations or possible deductions. Take a minute to write down an observation and make one guess based on the picture provided. Now, let's look at the next image, and as you can see, the story becomes a little bit more defined, or perhaps different from what our previous observations may have told us. Now write down two more observations based on what you see. What new information can we see from the tracks provided? Now that we see a new set of tracks, let's write down two more observations. Is there perhaps new information that can be gathered from the following image? Now, let's discuss our findings. If we were to answer these questions in complete sentences, would everyone have the exact same inference or perhaps educated guess? Explain why or why not. How is this activity like a fossil record? Hint, let's think of the fossil record as a puzzle. This concludes our presentation.